Happy to be on this call today. So what Jeff said, we're talking about doing some bridge case studies, performance practices, part two. Happy to be on here. We get going here. Just to give you a little bit about VNS Galvanizing. VNS Galvanizing, we have currently 9 facilities, currently across the Northeast, predominantly all the way from Boston, Massachusetts, all the way down to Millington, Tennessee. All of our kettle lengths are wide range. Two of our facilities, VNS Corns in Johnstown, PA, and VNS Amboy, they actually have spin operations where you could take spin small little pieces, thread nuts and bolts and splice plates. You can put them into a basket. They go through a galvanizing kettle and it goes to a centrifuge, and we actually spin the material. The location I'm based out of Lebanon, Pennsylvania, we have a kettle length of 55 feet long, 7 foot wide, 9.5 foot deep, with 20-ton crane capacity, where we do majority of our bridge work in our group. We've been doing a lot of bridge work here in the Northeast, predominantly over the past couple decades. So that's a little brief history about VNS Galvanizing. We're also part of Hill and Smith PLC, which is a larger conglomerate of a holdings company based in the UK. Just to give you a little bit, our first project here, this is a project we worked with about 2 years ago with Quality Bridge and Fab out in Pittsburgh, Ohio. They fabricate a lot of short span bridges from 140 feet and under. This was a bridge out towards outside of the Pittsburgh area, north of Pittsburgh in Mercer County. It's called the Tate Road Replacement Bridge. This was done, fabricated and galvanized 2 years ago. I'll get a little bit of the project. Um, so it actually is a little bit above the Otter Creek. It's very close to it. There's not that much clearance underneath that creek, so it does get flooded in the area a lot. It was originally constructed in 1966. The reason for replacement was it reached its service life. The reason what I said earlier, it gets flooded. There's a lot of vegetation in the area, so the county did a study. There's about 400 to 500 people that travel over this bridge a day. The span on the bridge is around 85 feet. It's owned by the Mercer County, Cool Spring Township. The bid date on this was back in 2023. Quality Bridge was working with the general contractor, the county engineers. They needed this bridge to go up quick because of the high volume of traffic. It actually leads to the county seat, so a lot of traffic comes out through in this every day. Project cost was around 600, little short of $650,000. Material was sourced that year and also galvanized in the same year. The reason why they chose steel was because of the availability, and also they were also looking at, in my next slide, steel versus concrete. The reason why they chose steel was because of the versatility on it, the availability. They also looked at painting it versus galvanizing. The reason why they chose galvanizing on our end for the county engineers is because the quick turnaround time you could have with it. It doesn't have to sit in a paint booth. We received the material, we checked it in, and we were able to get in a process that in a day or two after we received it, repackage it, and ship it back out. So, project was to proceed was in April of 2023. The completion date was in December of 2023. See the picture on the right here? This is actually the general contractor. It was Horizon Contracting. They actually excavated the area, took all the old bridge beams out. They did some testing on it that they needed to update this bridge to make it more safe. So that was some of the bridge replacement considerations that they had taken effect. Design considerations. The general contractor, VNS Galvanizing, and the county engineer, we all had to get together and uh, put all of our minds together to make this project successful. If you see this guardrail on the side here, the small little beams, the design team actually originally wanted to have these connected on the main members. I advised Quality Bridge called me up. I advised against that because the bridge span was about 85 feet, so it'd be a progressive double dip. So what we'll have to do is take the beam in, we dip it, take it back out, and dip it again. The reason why I considered that was just for better quality, also to minimize warpage and distortion on the material. Because some of the thicknesses, there was a lot of mixed material. When you get into uh, mixed material on pieces and it's not the same thickness, you run into the chance of warpage and distortion. We try to want to eliminate that. Um, they chose galvanizing just because the exceptional corrosion protection and the constant moisture exposure in this area. This area gets flooded a lot. There's a lot of high vegetation. That's why they needed to replace this bridge. Originally, the date was 1966, but over the lifespan of this bridge, it needed to be replaced. It was cost-effective replacement. It was able to get sourced really quickly and put back up to get back into service. If you see this on the picture on the right, you could see if you look past the little guardrails. So the beams were galvanized, the guardrails were galvanized, and also there was bridge decking that they put under it just because of the moisture content in the area. It allowed the bridge to breathe. So it'll eliminate corrosion and allow as best as possible. So there also is open grading on it. And this was all galvanized by VNS galvanizing for the most part. The only thing that was not was the bridge decking on this bridge. And this is the completion of the bridge, 85-foot span. Um, About 400, 500 people come every day. It's a cool little bridge, and at 85 feet, so it's in that short span bridge of 140 feet and under, and it's all galvanized, which is really cool to see. That you could take multiple products and you could galvanize different types of products at all different shapes and sizes. Next bridge here. This was the Assinat River Bridge. We worked with Griner Industries in Mount Joy, Pennsylvania. This was actually a railroad bridge up in outside of the Boston area on the it's called the Assinat River Bridge replacement. Um, Really cool project. It's a train bridge instead of a road or walkway bridge. We're seeing more of that over here over the past couple of years. We're seeing more railroad bridges getting galvanized because of the load capacity what these trains have. This was They submitted their bid in 2020. Griner did. We started galvanizing this, fabricating and galvanizing it at Griner in 2021. This is the reason for replacement was it reached its service life. It actually goes over the Assinat River. So it's the South Coastal Railway, which is actually owned by the MBTA. Um, so they did a case study on this. It's a commuter rail, and also too a lot of cargo goes through this area. It's a very high traffic corridor. It sits right above the Assinat River. A lot of moisture in the area, a lot of vegetation. And then I'm going to talk a little bit about the replacement here in a little bit, which is very unique on this bridge. Um, so the reason why they chose steel here, you're going to see a little video here of the South Coastal Rail. This is talking about, you're going to see the video that you're going to show the installation on it. So why they chose the steel was because of the accelerated construction schedule. So when it got to the site, they demolished the old bridge, put the new abutments in, and also too they got the steel on site, so they had to erect everything off site a mile down the railroad track and actually travel it down the railroad track to get it into place, what you're seeing here in the video. So accelerated construction, they were able to demolish the old bridge, put the new bridge up in 11 days. The other reason why they chose steel was because of its resiliency. It has a very strong structure. It's a lightweight superstructure. It could withstand, it's easy to move, easy to replace, and long-lasting durability. So compared to like other bridges out there, like concrete and other products out there, you get a lot of durability out of it. Even if when you put a galvanizing coating or any type of coating on it, you're going to get a lot more durability, and it's going to withstand a lot more years. So during the design considerations on this, there was a lot of design considerations. So our kettle length in VNS Lebanon, where this was dipped, is around 55 feet long, 7 foot wide, 9.5 foot deep. The bridge span roughly was about 144 feet. So we actually had to splice these beams so it could fit in our kettle. The size, the height of these beams was around probably around 6 to 7 foot. And when during in the original quoting phase, it was brought to my attention that the web to flange thickness was uh, out of that 3 to 1 ratio. So when you get into that 3 to 1 ratio, what I was telling you before earlier, that when you get out of that ratio, you run into the chance of warpage and distortion. These were plate girders. So with these plate girders, they had to actually beef up the web compared to the flange, and it had to be in that 3 to 1 ratio. So to minimize warpage and distortion. All the girders and beams and angles were galvanized on this project. Reason why they chose galvanizing is because it was by a river. It's in a high vegetation area. It's for the exceptional corrosion protection, the longevity and low maintenance cost that they wanted to, because it's actually a mile down the railroad track. They really didn't want to, they just didn't want to really touch it, only go out there for visual inspections. So something like that for longevity, it could last us between 85 to 100 years, depending on the atmospheric conditions before first replace, before you have to start thinking about coating and for lifetime first maintenance. And this is a completion of the bridge. This was completed back in 2021. You actually see on the left-hand side on the bridge girder where I said they had to splice it, you actually see the double dip line. This was actually this actually at our VNS Lebanon location actually pushed our capacity. Never did really did bridge plate girders this tall before, but it came out very, very successful. Griner was up here. Everybody had their eyes on it. So it came out a very, very successful project. But we're seeing actually more and more of this. I don't know if anybody's involved in ARIMA, but we're seeing more galvanized train bridges out there in the market coming to fruition. Next bridge here, this is the White Truss Bridge. This was galvanized at our VNS Taunton facility up in Boston, Massachusetts. The location of the bridge is outside in Jersey City. Um, this is actually a big train corridor in the local area. A lot of it's a commuter train for New Jersey Transit. Can-Am Bridges, which is based up in New Hampshire, in Claremont, New Hampshire. They were the one who fabricated it and shipped all the material to our VNS Lebanon location, or no, our VNS Taunton location. I'm sorry. Project background, the White Truss Bridge. It's over the St. Paul Avenue and Van Kuren Ave. It's a high traffic area with a lot of traffic going underneath. Um, they needed to put this bridge up right away, so the bridge wasn't closed down, shut down. Um, Reason for replacement, it's reached its service life and the structural integrity. Originally, this bridge was actually put up around in the 1920s. They did some testing on it. They said, hey, the structural integrity, just with all the heavy traffic in the New Jersey metropolitan New York area, that they needed this bridge needed to be replaced. And so it's owned by the New Jersey Department of Transportation. Um, and the reason for some of the bridge replacement considerations was the freedom and versatility of steel. There was a lot of considerations, a lot of prefab meetings going into this. That job site was in a very, very tight spot. So what we had to do is get on with the general contractor, the design team, and VNS. We had actually had to come up with a solution because a lot of the stuff they couldn't do the pre-assembly on site. So what we decided to do at VNS, we offered a service. We'll galvanize the material, but we'll also do the connections at our place. So after the material was galvanized, what we did, we took the steel, we got all the piece marks together, and we did a bolt-on assemblies at our site. So we did all the splice plates, all the angles. We all connected them together at our site so they could go to the site, so it could be a faster erection time. So there's a lot of planning involved in that. It was a cool, fun little project. It's really nice when you see the design team, the fabricator, general contractor, and all your subcontractors getting involved and seeing how successful a project like this could be. Another design consideration that was talked about. So this span is about roughly, probably say roughly 180 feet in length. Um, and the main members, they didn't want to splice, just because of the due to the kettle sizes up at our Taunton facility. They only have a 29-foot kettle. Um, so what they did, this is a cool little project that they actually metallized and galvanized the secondary components. So the main members were actually metallized at Claremont at the Can-Am Bridges facility. Um, and all the secondary members, splice plates, the diaphragms, beams, angles, was all galvanized by V&S Taunton, all the smaller members that could fit in our kettle. So you see here on the left-hand side, that's the main member. It's a metallized beam. And on the top there, you see some of the cross frames, cross members. So it was actually too long for our kettle. So you actually see the double dip line. So we actually had multiple pieces that were metallized, pieces that were double dipped, progressive dipped, and also single dipped. So you can actually mix and match different bridge components with metallizing and galvanizing to have a successful project and meet those project deadlines. Galvanizing and metallizing go hand in hand. They're a little bit different. Actually, metallizing, it's with the spray application. It actually sits on top of the surface. Um, with galvanizing, it's a metallurgical bond that actually happens. So that actually the steel, the galvanizing, the zinc actually becomes one with the steel. So two different types of products, but able to achieve corrosion protection. And that is completion of the project. And this was fabricated in 2024, 25, and was able to be completed in 2025. So cool little truss bridge project. You have multiple of applications that you could put on with that, with metallizing, galvanizing, all different types of structures. And does anybody have any questions?
One thing that we wanted to talk a little bit about today is another very cool project that we in St. Louis at AZZ were able to be a part of. We worked with a lot of, I guess, a pretty great project that went through Missouri. MoDOT's influence on this was to try something and make a large impact on the rule bridges across Missouri. As we've seen a lot of times, those can be a little bit denied some TLC over time, but through a really great new design, which I'm sure you're all aware of and we'll get to, we can make the repairs, changes, and even replacements a lot easier over time. A lot of that has to do with the involvement of using galvanized steel opposed to some of the others available. So what we're going to go over here today is the overall corrosion challenge, galvanizing and some of the alternatives, the impact of steel on the design for that SDCL method that we'll get into. We also, at AZZ, we've been really trying to expand our availability to bridge the overall bridge market. We understand that running longer material can be a headache for a lot of galvanizing plants just due to the actual capacity of the buildings that we're in. But we're trying to make some strides there, as well as the case study itself for what this project was, which is the Farm Bridge project, where we tackled 31 bridges and alongs with DeLong's steel, as well as MoDOT. And yeah. So first up, the corrosion. We all know it's a persistent threat. All the DOTs are very, very aware of this over time. It's across all the structures, but one thing that's really good on this is this rule bridge project, because it gives vital lifelines to these rural areas. It's very hard to do any sorts of repairs or replacement of them because you have to completely shut down the lifeblood of an entire community. So if you're going to replace a small bridge that takes normally 30 minutes to get to work, well, now it might take an hour and a half because you have to go so far out of your way. In this particular project, the budget target for MoDOT was around $26 million. Again, that was for 31 bridges. Our target was 75 plus years for maintenance-free services by utilizing hot tip galvanizing. And overall, that involved 527 tons of hot tip galvanized steel. really one thing that we wanted to touch on, this isn't obviously the case for every type of project, but the ones that we were looking at just here for this particular project, for the farm build project, really galvanizing won out. When DeLong's was able to look at the overall scope and make their bid package to MoDOT, they realized that for these reasons of corrosion resistance, really low maintenance costs over decades of time, field damage, how zinc is sacrificial to itself and will heal itself over time, it will not let rust spread throughout the entirety. As well as the installation speed was really key on this as well, that it made us as galvanizing the lowest overall cost for the project, which was very nice. And hey, Jeff, I think Adam actually just got back on. If you want to, if we can relay it over to him, I don't know if you want me to continue.
Let's go ahead and make. Okay, did he? I don't see him as a panelist.
Yeah.
No.
Then we can just keep riding along.
Okay. All right, false alarm.
Yeah. So reinforcing the economic case, this slide really resonates with our budget owners. One, it's no coating maintenance, meaning no reoccurring paint cost over the structure's life. The zinc iron alloy delivers 75 plus years of maintenance-free service. Even in really rules exposure, we expect that to go much beyond that. The durability and just fast install structures means less commuter disruption. Again, that was a really big thing that MoDOT was trying to keep in mind for this, was just the impact on the overall community. And also one of the upfront coding decisions gives the DOTs predictable budgets instead of unpredictable future repair costs, and what that type of impact is going to do to their future budgets. So really overall, it really helps you adjust up front and know what your overall life expectancy and cost are going to look like. The great thing about the simple for dead load, continuous for live load, it really uses just a simpler design that will allow for more steel. A lot of these were wooden, that we even saw in some of the pictures that Gary Wish sent to us a while back. But really the fantastic thing that I like about it is that you can make repairs and replace parts by not shutting down the full bridge. You can shut down half of the bridge, and that will still allow for two-way traffic. So when it comes to being in the field in these areas, it really is going to decrease that communal impact. The rolled beams that they use, they're not using plate girders, so no flange cutting to the webs, no welds to complicate the coating as well. Everybody knows you don't want to be welding on top of galvanized steel. If you do, you can get pretty sick. But so no bolted field splices. It's a much cleaner erection, and faster overall. Optimized for a uniform coating. Obviously, the fabricator and the galvanizer, we have to collaborate, much like Alec was talking about with the venting and draining. For all where the welds are going to be, we can try to mask those. And that really made for an easy transition into this project because they just got us involved in the very beginning. If you're ever working on a project like this, please reach out to your galvanizer, whomever it is, and let them look at the prints. We can save you a lot of money by looking at these up front, by giving you some insights to where to put holes, how big of holes. That way we're not doing it after the fact. If you can get in front of it a lot earlier, the overall design and look of the material will be a lot better. One thing Alec touched on too, as girders continue to get longer, there is the issue of distortion and warpage. There's that concern. To try to safeguard against those elements is much easier to do up front in the design aspect, as opposed to all of a sudden sending some large member to a galvanizer and realizing, oh my gosh, we got to put on stiffener plates and that might still not even work. It can really be a mess. So please reach out to us ahead of time. That's one thing that I know galvanizers love, is to be involved in the very, very beginning stages. We would like to just be there from an advisory standpoint. Obviously, it's still y'all's decision on what you want to do, but it's something that we really like to be a part of. And I think the the end results really prove themselves that's the best case scenario for the whole project. Again, this was something kind of cool that we've been working on. So in our Joliet facility, not too far, we run a lot of DOT work up there, a lot of bridge members up there. Our kettle's not massive. It's only 51 foot, 12 foot deep, or 51 foot long, 12 foot deep, and 8 foot wide. However, last year we actually dipped up to 94 feet for a length. That was not a girder. However, it was a continuous piece of steel. Along with DeLong's teaming with Hillsdale Alberici for a very cool CTA project a couple years ago, we were able to actually dip an 88-foot girder successfully, multiple of them. It was one of the coolest things I've ever seen. It was seeing a lead car with an 88-foot girder and a follow-up car. It was 5 of them going down the highway. It seemed like a quarter mile or so, just nothing but continuous girders. And it's something galvanizers get really excited about, that's for sure. But it was a really cool project to be a part of. We were able to get in that design function early on, and it really eliminated any warpage, distortion. And they're actually up now in Chicago. If you're ever around those red and purple lines on the L train, you'll be able to see them. It's very cool. One thing we're pretty confident that we can do, we haven't gotten the opportunity to try this for a girder or a bridge, any sort of bridge material yet. We're pretty confident in Joliet we can do 100 feet. We'd have to really look at the design itself to make sure that it fits within the parameters of our building and operation for safety, safety reasons, as well as we don't want to put holes on the side of the building. But we're pretty confident we could try it. So if anyone wants to try, give us a ring. We'd love to be in part of the design and give it a go.
Hey, Joe, real quick, could we
Yeah.
get you to click the hide button on the Zoom app as sharing your screen? We had a couple requests from attendees.
Where is that at?
It's just right next to stop sharing. Should be Sid hide. I don't know. It's
Oh, hi. That?
yeah, there we go. Okay, awesome. Thank
Cool.
you.
Yeah. So fixing access to rural Missouri. This is the big project that we really wanted to discuss here. MoDOT was set out to replace dozens of these weight restricted bridge. Again, a lot of them were wooden. They were all in very poor condition, carrying two-way traffic on a single lane. It was pretty bad, even dangerous to some degree. And so the solution really was to use that new bridge design and incorporate more galvanized steel. What's cool about it is you can actually use less steel, and as long as it's galvanized, you can use less of it, and you still get longer durability and functionality out of it, which is really great. So again, we teamed with Gary on this one. His team addressed MoDOT's concerns about the corrosion protection, durability, and at the end of the day, whenever it was all concrete or a mixture of different steel and coatings, DeLong's really stood out by using hot dip galvanizing steel because it guaranteed that superior corrosion as well as longevity, and we could just get it done quicker. In St. Louis especially, we can slam steel through there at a very, very high rate. So we were able to get all this material out very quickly, and it allowed them to have minimal downtime at job sites. The results by the numbers on this one. So 31 bridges were impacted. 27 of those were steel supported structures. So not all of them were just steel. 527 tons of steel galvanized throughout the entirety. The longest single bridge we had was 115 feet. Not terribly long. Obviously, that took multiple sections. That wasn't just one continuous girder. But the project budget was $26 million. And they were actually able to meet that budget on time, which was a huge success. So we're very proud of that. To go back to this, a galvanizer and fabricator partnership. Alex touched on this as well. To get us involved in the beginning, DeLong's really went above and beyond by letting us come on their site, review all the plans. We were able to suggest different venting and draining techniques just to make sure that the actual field inspection of everything went very smoothly. There was no rejections, there was no questions, and all that has to do with providing a very uniform coating that exists because of these certain design implementations. So it was very nice to be a part of that. It also helps with, again, different costs that can come up down the road. If you don't catch it early, it can become a huge headache for a fabricator after the fact. So it's very hard to go back and change anything after you galvanize it. It's quite easy to do so in the steel planning stages. Mask for different field welds. Again, you do not want to be galvanizing on galvanized steel. Make you very sick. So for specific structures or surfaces, we were able to mask using different methods. Everybody's kind of got their own feel of how they like to mask against galvanizing. Really, all we're trying to do is impede the steel from going through our pickling processes. We use acids to clean that steel to get down to that base material. It's only then that actual metallurgical bond that galvanizing provides will take place. So I think in St. Louis, we use a lot of 100% pure silicon. We've even used high temperature paint that you can roll on. We've seen a host of different products. If you'd like more information on that, I'm sure there's plenty of us on the line that would love to give you many examples of different types of products that have had success. But again, either way, you're trying to just get in the way of the steel itself, cleaning all the way down to its bare steel. For staging and delivery, we were able to, because it uses less steel, it doesn't take up a giant amount of yard space. It's easy to stage these different sets of bridges, in terms of the way that they're going to be erected. So it was actually really great for us to work with MoDOT as well as DeLong's and minimizing any commuter disruption, because we were able to provide them exactly what they needed on time in staged versions of itself. And that really just poured us into, the install. Galvanizing the members, it really just made it ready to go up. The timelines were very fast, and now they're ready to set to go. So hopefully there's no disruptions. I don't believe that there should be any for at least 75 years. In those rural areas, there's really low impact to the durability. It's a lot different than if you're going to put it into, say, some sort of waste plant or something like that that's exposed to many different chemicals and ruggedness. This is something that's just going to last and be stable for a very long time. So what I was told is that this was kind of used as a new benchmark for rural infrastructure. It's been a hot button that I know the U.S. has really tried to tackle across multiple different DOTs. Galvanizing has delivered a superior corrosion resistance with that low life cycle costs. And it's really due to that SDCL design. It really simplified that fabrication. It pairs perfectly with galvanized steel. The capacity for our girders, again, are up to 94 feet. We'd like to try to hunt at 100 feet. If anyone's interested, please give me a call. And the overall project exceeded expectation and is now, I think, being used as case studies across DOTs all over the U.S. So we're very proud to be a part of that, especially very proud to team with the AGA. They awarded us and DeLong's an Excellence in Galvanizing Award a couple of years ago for this project. So it's been a very, very great partnership for us. So let's protect your next project. Again, please reach out to us from anything when it comes to girders, when it comes to design. We can be here to support you. Our overall methods, our overall goals are just to make your steel structures last for a very long time. I know it's very important for a lot of people to work on projects that they want to be able to show to their kids, their grandkids. Galvanized steel will last generations. So hot dip galvanizing for these steel bridges. Hot dip galvanizing steel has been used for bridge designs for decades. It's economical, it's long lasting. Minimal maintenance. Again, we can do these minimal maintenances in the field. Alec touched on metallizing. That's always a great method. There's also different types of cold application, whether that be a spray application. There's different types of zinc soldering that we can do in the field as well. It really mitigates the need to have to shut down a bridge section, put tarps everywhere, have to be cognizant of if you're sandblasting off paint, or if any other deterioration is falling on cars from, say, concrete or anything like that. It's really easy for us to actually maintain this while it's in the field. It's very low cost. The best practices do matter, so the design and the service environment for best practices ensure the highest quality and the longest lasting bridges. But again, if you don't fully understand galvanizing, please reach out to us. We love to be a part of that educational experience and that journey. We love to go into different engineering firms, DOTs, or even fabrication shops, and just understand the benefits, but also know the limitations that we have to make sure that your project is right and it's successful. The AGA, that's been a huge benefit to not only the industry, but to also AZZ. They're a nonprofit trade association dedicated to serving all different types of galvanizers, fabricators, architects, engineers, and just all different types of specifiers. Please reach out to them, to us. We're all happy to be a part of just the overall education of the market. We'd again love to just come on board, whether it's at even at an engineering school. We've been trying to get more involved with that too, to try to start teaching younger persons who will eventually be those decision makers, just to get to know more about the industry, more about what to expect, and really how to really reach those successful benchmarks of great projects. And lastly, this is just the purposes in learning. We want you to understand the process. The design especially is critical. Identifying which specifiers are using those hot dip galvanizing or choosing hot dip galvanizing. And then we'd also like to also teach everybody how to inspect and repair for the future. So please let us know how to help, and thank you for your time.